Okay, let's take a look at one of these rewind questions all together. Which one do you want to do? Pick one. 1, 2, 3. Two because it looks longest? Okay, let's do 2 because looks like it might be the hardest. So let's take a look at number 2. I'm glad you guys didn't say 3 looks that hard. It just has fractions. Doesn't make it hard. All right, so let's get... Oh, man, I thought I could get rid of everything at one time. Oh, it's typed in there. Okay, well, ignore that one. I'm going to rewrite number 2 so we have plenty of room for it. So 3x plus 4 parentheses 2x plus 3 equals 93. All right, where would I start? Where would I start? I probably need to simplify first, so I want to simplify to get rid of those parentheses, which means I'm doing what property? So I'm distributing the 4. For the most part, people did a good job when they were doing this at their boards. My concern is that people are forgetting to distribute to the second number, which is a very common mistake people make. You just get started going and you go really quickly and forget that. So that's why I always put the arrows, because it helps me remember to distribute to everything. I don't distribute the 4 to the 3x. Why not? Yeah, it's not in the parentheses. It's on the other side. So that's just going to stay 3x plus, what's this going to give me? 8x plus 12 equals 93. Good. Okay, now what am I going to do next? Combine my like terms. So I'm going to put stuff together if it's on the same side that I can put together. So together I'm going to collect my 3x and my 8x because they have the same variable, same exponent, which gives me what? 11x plus 12. And now we've got just a very basic multi-step equation. So what do I get rid of first? By doing minus 12. And I end up with 11x equals, because that went away, and then this gives me 81. How would I finish? By 11. And I end up with x equals, does 11 go into that equally? No? So I'm just going to leave it like this. All right? It would be like 7 point something, 7 something. All right, but I'm going to leave it like that. I don't even need to reduce it because it doesn't have any like terms that I can reduce it by. Okay, so was it the longest one? Probably. Is any of the math in there that difficult? No, but you do have to be really careful with keeping track of your stuff, right? This would be a difficult one if you were the type of person who tried to work in their heads all the time, right? So this is a challenging problem if you always work in your head. If you do it and write it out, there's not really that much difficult math happening. It is hard to keep track of everything though. Okay? All right, so what we're going to talk about for this second part of the lesson is solving equations that have variables on both sides. So sometimes you end up with an equation like this. And in this equation, we have a 7k equals 4k plus 15. Does anyone have any ideas about what we need to do? Let's still remember the goal of algebra is always to what? Get the variable by itself, right? In this case, what's our variable? Okay, so we still want to isolate the variable. Okay, Jesse, you have an idea? Minus 4 what? Good. I want to collect my variables on one side. And it doesn't matter which side. Here it makes more sense to collect my variables on the left side because I can move the 4k over. How do I move 4k over? Minus 4k, right? Here it's a positive, so I do a negative 4k, just like I would do if it were a whole number. I move it as if it's a whole number, except I have to move it all together, so I keep 4k together. What happens to it here? Goes away, so all I have left on the right side now is what? 15. And then over here, what do I have? Exactly. How come I had to subtract the 4k from the 7k and not the 15? They're not like terms, and I have to do it on the other side of the invisible wall, so the other side of the equal sign. All right, and then how would I finish? Divide by 3, and you end up with what? Good. K equals 5. Perfect. Okay? So just because there's variables on both sides, does it make it that much harder? No, it doesn't even change what you're doing. You just have to collect your variables first. Okay? And when I say collect your variables, what I mean is get all your stuff with a k on one side and all your stuff that has no k on the other side. Now, it can be k's on the left, numbers on the right, or it can be k's on the right, numbers on the left. It just depends on what's going to work out better. But moral of the story, get your k's together, get your numbers together, and then isolate your k or your x or whatever your variable is. Israel, can you put that away, please? And can you get the slides for the lesson we're on, or at least be paying attention to what we're doing up here? All right. What am I going to have to do here? I'm going to need to do some collecting with my variables and my numbers, right? So I'm going to need to move multiple things. Guys, you don't have to get them right now. It's okay if you don't. You can get them when you go to your boards. So I'm going to have to move multiple things because I've got a bunch of stuff here, right? I've got 4 terms here, and I need to deal with them. But the first thing I want to do is probably collect my x's. And it makes the most sense for me to subtract the 3x or subtract the 5x. Probably 3x. Does anyone know why it makes the most sense to do that instead of the 5? Yeah, then you end up with positive numbers. So we want to move the smaller one, right? Because if you move the bigger one, you end up with what kind of number? Negative. Sometimes are you going to have to do that? Yes. But if you can avoid it and keep it positive, it's way easier to do that. So I'm going to do minus 3x. And if I do minus 3x, where else do I do it? On the other side, underneath the... Why does it have to go underneath the 5x, Dejane? Yeah, and I have to do the x underneath the x, right? Because I can't subtract it from the 2 because the 2 doesn't have an x. So I can't do anything with it. It doesn't have a variable. So then what happens with it over here? That's gone. So what do I have left on the right side now? Just a 4. What do I have left on my left side? 2x minus 2. Very good. Still have the minus 2. Haven't done anything with it yet. Now what do I want to do with it? I need to add it because it's a minus 2. So if I add 2, where else do I add it? And I end up with 2x equals 6. Now how do I finish? Good. Divide by 2. Perfect. And I end up with x equals 3. Could you do this and this in the same step? Yes. I am fine if you want to do, like if you look at this and you think, okay, I'm going to need to move the 3x, but I'm also going to want to move the 2. So you do the plus 2 in the same step. That's fine with me. But again, if you're getting them wrong, take it slower. Okay, so if you've never done this before and you've never seen it before, I always start by doing it one step at a time. If you've been doing this for a while and you can do multiple steps at a time, by all means, go ahead. Okay, but when you see me do an example, I'm going to do it out like this. Okay, what do I do here? I have to, Zulema, do what first? I have to distribute here first. I can't divide by 2 yet because over here this has a what? A y, so I would end up with a fraction I don't want. So I'm going to distribute this, which gives me what? 12, very good. All right, now what? Subtract 2y. Exactly, I want to subtract the 2y because again, I usually want to subtract the bigger or smaller? Smaller if I can, because then I'm going to keep it positive. Minus 2y. So in this case, my y's are actually going to end up being on the right side. Is that okay? Yeah, totally. It doesn't matter where they are. What's 3 minus 2? 1y. Do I need that 1? No? I can just write it as y. And then what do I have left here? So I'm done, right? That's it. Okay? If you had a 1, you would divide by 1 and you'd still end up with 12. Okay? So it's just an extra step you don't need. All right. Questions on those? Hang on before you get up. All right. So when you're looking at these, I had to remind myself. Okay. This is the thing I want to talk to you guys about. What if you have something like this? What is that, Elijah? Yes, exactly. You have a negative on the outside of the parentheses, which means you have to distribute the negative. When you distribute a negative, what happens? It just flips all your signs, right? So this becomes what kind of x? And then this becomes what kind of 8? Negative 8. What if it were already a minus? Become a positive. Very good. So be careful with that. And then this gives me 16. Okay, now what? Add 8. Add 8. And I end up with what? Negative x equals 24. Can I leave it like this? No, because negative x is not a thing I want. How do I make it a positive x? By making this a negative 24. Good. So just flip your signs. Okay? All right. So remember, distributing a negative works just like distributing everything else. Goes to everything in the parentheses. Okay, go try these practice problems. All right, eyes up here. So let's look at 14 together really quickly. On 14, I mean 11, which starts with the number 14. Okay, so number 11, 14 equals negative p minus 8. What do I do? Distribute the negative. So if I rewrote this problem, what would it actually look like? Plus 8. Very good. So it becomes a plus 8. So then what do I do here? What's 14 minus 8? Equals what? So then my answer is actually what? P equals negative 6, because I can't keep a negative variable, but if I change the variable to a positive, then the 6 had to become a negative. Good. Okay, so just take that one slow. Be careful with those. All right. Let's look at this one. Let's take a look at this one. So there's a lot of x's and a lot of numbers going on. So let's collect our like terms. But even before we collect our like terms, whenever I've got an x by itself, what does that actually mean? Zulema? 1x. So I want to write that in. I'm going to write 1x because otherwise I'm going to forget what it means and I don't want to do that. Okay, so is there anything on the left side that I can combine? 6x and the 1x, right? This is a 1x. This is a negative 6x. So what does that really give me when I combine it? Why is it a negative 5x? Yeah, are my signs different or the same? Different, so I have to subtract and then keep the sign of the bigger one. So negative 5x plus 4. And then over here, is there anything I can combine? 6 and 2. So 6 minus 2 is 4 minus 5x. Okay, so now am I done combining? Yes, I'm done combining. Now I can move to doing opposite stuff. Remember, if you're combining like terms, you're not doing the opposite. You're just putting stuff together based on what the signs are. So now what would I do next? Okay, I need to add 5x. Which 5x? It doesn't really matter. So I'm going to say plus 5x. Where else do I need to add it? Over here to the 5x. Not to the 4. How come? They're not like terms. Okay, so I need to add those. What happens here? Those are gone. What happens here? Huh. So what do I have left? I have nothing left. That's 0. So what do I really have left here? 4 equals 4. What happened to my variables? They canceled out. They disappeared. My variables are gone. And I am left with 4 equals 4. Is that true or false? True. 4 is equal to 4. So this is a weird situation because my variables have disappeared. I have no variables left. That does not mean x does not exist. What this means is if it's true, 4 equals 4, that means we call this all reals. Or all real solutions, which means no matter what I plug in for x, I could plug in 1, 2, a million, negative a million. No matter what I plug in, it will work. in this equation. So whatever number I plug in, it will work. And I know that because when my variables disappeared, this is true. 4 is equal to 4. Okay, so we call that all real solutions, which just means anything you plug in for x, or whatever your variable is, will work. Okay, whereas back here, I'm going to go back for a second, but I'm coming back here. So whereas here, the only thing I could plug in for x was what? Negative 24. If I plugged in something else, would it work? No, it would not give me an equivalent statement. It would not work. But here in this long equation, if I plug in anything, it will work. And that's what we call all real solutions. Yes? Yes, exactly. So if you really take a look at what's happening in these equations, you could figure this out without doing any math, because you can recognize that all of this is really the same. Negative 5x plus 4 is exactly the same as 4 minus 5x. Because those of you that keep change flip, this is what you do when you keep change flip. 4 minus 5x is the same as negative 5x plus 4. So yeah, it's the same exact equation, just it looks a little bit different. And no matter what you plug in, it's going to work. Now, do you think this happens a lot or not very often? Not very often. It doesn't often work that you can plug in anything for x. So don't just start rampantly writing all reals on answers just because you are like, I don't want to do the work for this. It's probably all reals. No, it's probably not. Okay? It doesn't happen that often, but when it does, this is the answer. Okay? 4 equals 4. If you get here, good. But you need to recognize that what does that mean? That means your answer is actually all real numbers. So every single number would work here. All right, let's look at this one. What would we do first here? Combine my like terms. What are my like terms on this side? So negative 8 plus 9, which is 1x. And I still have what? Plus 6 equals negative 17 plus x. This is just an x. What do I put in front of it? Okay, now what do I need to do? Minus 1x, because I want to get those now on the same side. Okay, what happens? Again, what happened on both sides? My variables canceled out, and what am I left with? Is that true? No. If you owe me $6 and give me negative $17, that is not fair. I would be mad. You just stole $17 from me. All right? So that is not true. So that means that this is what we call no solution, which essentially means that there is nothing that you can plug in for x that will ever make this equation work. There is no answer in the planet of numbers that are real numbers that will ever make this work. Okay, so there's no possible way I could plug anything into this equation that'll work. Do you think this happens a lot? No. Neither of these happen that often. More often than not, you can solve it and you will get one answer, like we've been doing for the past 3-4 lessons, right? Where x equals some number, x equals 5, x equals negative 6. For the most part, it will be one solution, where x is actually equal to a number. There will be times where your variables disappear, and it's either all reals or no solution. And how do you tell the difference again? When is it all reals? When they're equal, when it's true. All right? And when is it no solution? When it's not true. 6 is not the same as negative 17. This does not happen a lot. So again, on a test, if you don't know how to do anything, don't just start writing no solution all over everything. Okay? It's not usually right. But it is a weird situation that happens sometimes where the variables disappear and it's either all reals or no solution. Now, keep in mind, on the practice that you're doing next, since we just did this, they are all going to be either all real or no solution. That's not normal, So don't be like, you just said this doesn't happen that often and now it's happening 12 times. It's going to happen a lot on the practice because we just did it, okay? But again, how do you recognize a no solution? It's not true. And how do you recognize an all reals? It is true. But your variables have to do what? They have to disappear, basically. Your variables have to disappear. And when your variables disappear, that's when you know it's one of these weird things. Okay? So go try... I think I want you to just do 2 of them. All right? So go try number 1 and... No. 9. 2 and 9. Go try 2 and 9.